right, so imagine this was your situation, that you wanted to build a garden and you needed 13 square yards of soil to fill your garden. And for whatever reason, again, maybe you're growing tomatoes, maybe you're growing whatever you're growing, whatever it is, squash, whatever it does best at 34% clay. So I'm going to say that. So what we want is we want 13 yards. Oops, I'm going to do a better job of that. We want 13 yards of soil that's 34% clay. That's what we want. What we actually have, however, if you go to Home Depot and you say, "Hey, I want to buy 13 yards of 34% clay soil," they say, "We don't have that. Sorry, you have two options. You can buy soil that's 28% clay, or you can buy soil that's 54% clay. Those are the only options you have." And so, but you want 34% clay. So how are you going to solve that, or how are you going to figure out how much soil of the 34%, I'm sorry, of the 28% clay, and how much of the 54% clay are you going to do so that when you're done, you end up with the 34% clay? That's the option. That's what we're trying to figure out here. Okay, so the first thing that we do is let's set up a little chart, and I already put this chart here for you. And what we know is we have three different kinds of soil. We've got soil, I'm just going to call it soil A. You can call it anything you want. And that soil A is 28, well, first of all, even before I do that, let me go back. I'm not going to put that yet. What I'm going to do is I'm going to say, let's first figure out what the formula is. Okay, so we've got some volume of stuff. And if I take that volume and multiply it by the percentage, I end up with what I'm going to call the pure volume, how much actual clay would be there. Okay, so for example, what I mean by that is, let's start with the first type of soil I can buy, which is 28% clay. There's a second type of soil I can buy, I'm going to call it B, which is 54% clay. And then what I want, I'm going to call C, that's what I actually want. I want 13 yards of it, 13 cubic yards of it. That's 34% clay. So I'm just setting this up here. Now, what can I do? Well, what I can do is I want to figure out, first of all, how much actual clay do I want in that 34% clay? How much clay is here? So if I take 13 yards of soil and it's 34%, if I multiply that together, that's the same thing as having 4.42 yards of clay. Of that 13 yards of soil, 4.42 or 34% of it is clay. Now I want to find out, well, how much of soil A do I want? And the answer is, I don't know. That's what I'm trying to figure out. And of course, in algebra, all the time we have values we don't know what they are. We're trying to figure them out. And when we have that, we use a variable. So I'm just going to call it, for this example, I'm just going to call it A. So what is the pure volume of this? How much clay comes from that? Well, just like I multiplied the 13 times 34% to get 4.42, the amount of pure clay that I'm going to get, the pure volume, would be 28% times A, would just be 0.28 of A. Again, I'm just filling in this chart here. So now, for B, what's the volume? Well, I don't know what the volume is, so maybe I would just call it B. But now I have two variables, A and B, and that's harder to solve for two variables than one. So is there a way that I can fill in this box here using the variable that I know? And the answer is yeah, because I know that A and whatever is in here together, when I add them up, it's going to be 13 yards. So the volume I would have here is 13 minus A. And if I take A plus 13 minus A, when I multiply that out, that would just be A plus 13 minus A. A minus A, those go away, and I'm left with 13. That's what I want right there. So yes, that would be the appropriate volume for this. So I know that this is 13 minus A. And if I multiply these along, 13 times 54%, that would be 7.02. And then I have to then negative A times this, if I distribute, would just be minus 0.54A. Now that I have solved it, now that I have filled in this chart, the rest of it is just creating an equation. Because what I know is that I know however much pure clay I have here, if I add it to this one here, it's going to equal this one here. So in other words, 0.28A, if I take that and I add that to the amount of clay I have in B, which would be 7.02 minus 0.54A. If I put all that together, add those two together, that's going to equal the amount of pure clay I want right here, which of course is 4.42. So now, this is just like the equations we've been doing. This is just a multi-step equation. So the first thing I would do is I would combine my terms, 0.28A minus 5.4A. If I put that together, that's going to be minus 0.26A. Bring this down, plus 7.02. That's going to equal 4.42. Then if I subtract out negatives, if I subtract out 7.02, if I do it on one side, of course I have to do it on both sides because of balance. Do that out, and I get negative 0.26A is going to equal, subtract all this out, that would be negative 2.6. So I have one more step to do. I have negative negative 0.26A times A. I don't want that. I want to get A alone. So the opposite of times negative 0.026 is to divide by 0. Negative 0.26. And if I do it to one side, I better do it to the other side. And that cancels. So on the left side I have A, and on the other side negative 2.6 divided by negative 0.026, a negative divided by a negative is a positive, and 2.6 divided by 0.26 would just be 10. So now I know that A, which is the one that is 28% clay, I want 10 yards, cubic yards of, I'll call it A, which is the 28%. And then, of course, for B, to get B, if the amount of B I want is 13 minus A, and A is 10, that would be just 13 minus 10, which equals 3. So I want 3 yards, cubic yards, of B, which is the one that is 54% clay. And so if I go to the store and I say, hey, I'd like to buy 10 yards of your stuff that's 28% clay and 3 yards of your stuff that is 54% clay, and I bring it back to my garden and I mix it all up really well, I'm going to end up with what I want, which I wanted in the first place, which is my 34% of 13 yards of 34% clay. All right, so for this problem, we're going to mix two things. We're going to mix 12 gallons, oops, try that again, 12 gallons of 45% acid solution. And we're going to mix that with 3 gallons of pure water. Pure water is essentially a 0% acid solution. And then we want to find out, well, we make a new thing, what is the concentration of that mixture? So we're going to have three different things here. We're going to have A, we're going to have B, and when we mix them together, it's going to turn into C. And what we know is that if you take the volume of the liquid and you multiply that by the percentage concentration of acid, you're going to end up with the pure volume, what I'll call the pure volume, how much 100% pure volume of acid is there going to be. And so A, we know we have 12 gallons. And 12 gallons of 45%. And so if we just do what we said, we multiply these, volume times percentage, what is 45% of 12 would be 5.4 gallons. So essentially, A has 5.4 gallons of pure acid in it. B, we know, is 3 gallons. The percentage of acid of it's pure water, so it's 0%. So how much pure volume of acid is in this one? Well, 0 gallons. We have none. For C, we do know some stuff. If you take 12 gallons of stuff and add it to 3 gallons of stuff, you're going to end up with 15 gallons of that new mixture. If you take 5.4 gallons of pure acid and mix it with 0 gallons of pure acid and add them up, you're still going to have just 5.4 gallons of acid. And so what is the concentration of the mixture? That's what it's asking us. That's what's right here. We don't know. That's the whole point. We're trying to find that. So we'll call that X. So this concentration, X, is equal to, well, the concentration is the pure volume, so that would be 5.4 gallons over the 15 gallons of solution that we have. Okay, so the gallons, those are going to cancel. And if I divide 5.4 by 15, that's going to equal 0.36, which of course is equal to 36%. So our answer is going to be the new mixture, the concentration of the new mixture is 36%. All right, so this problem is about metal alloys. And it says, how many pounds of a metal alloy containing 70% iron must be combined with 7 pounds of a metal containing 20% iron to form an alloy containing 35% alloy? So once again, we have A. But first, actually, what I should really do is I should say, okay, what we have is we've got the weight of something, how many pounds we have. If we multiply that times the percentage, that's going to equal the pure weight. How much we have of pure, in this case, iron. So we have the first one is A, which is 70% iron. The second one is B, and B is 7 pounds of 20% iron. And we're trying to make one, C, that is 35% iron. So let's put in the values we have in our chart. Okay, A, how many pounds of a metal? We don't know how many pounds, so we'll call that X. And we know that it's 70%. You know what, rather than calling it X, why don't we call it A? It's probably an easier thing to do. We'll call it A, it makes more sense because we're doing A. Okay, so we'll call it A, 70%. So when we multiply those together, that's just going to be how much weight of iron do we have from A? Well, 0.70 A. Just multiply these together. For B, it tells us we have 7 pounds, and it's 20%. So if I multiply 20% times 7, I know I have 1.4 pounds. And so for C, how much is the weight going to be together? Well, it's A and B together, so it's going to be A plus 7. What's the percentage going to be? Well, it tells us what we want is we want 35% iron, so it's going to be 35%. Multiply this together, so I do it this way. So we know we have A times 35%, which is going to be 0.35A, and we have 7 times 35%, which is going to be 2.45. Now, what we know is we know that if we add how much pure iron from A we have, which is 0.70A, and we added that to how much pure iron we have from B, which is 1.4 pounds. If we add those together, we're going to get how much we have in C, which in this case is 0.35A plus 2.45. So to solve this, this is just like one of the many problems we've done before. So first I'm going to subtract out 0.35A and to get rid of this one. And if I do it to this side, I have to do it to this side as well. That cancels. That was the whole point. And so we're left on this side with 0.35A plus 1.4. And that's going to equal 2.45. Now if I subtract out 1.4 from both sides, that cancels. That was why we did it. 0.35A equals, that would be 1.05. Now I have 0.35 times A, the opposite of which, of course, would be to divide by 0.35. And if I do that to one side, I have to do it to the other side as well, 0.35. So now those cancel, and I'm left with A equals 1.05 divided by 0.35 would just be 3. So how many pounds of a metal containing iron must be added to 7 pounds? The answer is add 3 pounds. 3 pounds of the metal containing 70% iron. All right, so Amy mixed together 3 liters of brand A juice. So she put 3 liters of brand A fruit juice with 7 liters of brand B fruit juice, which contains 15% juice. And we want to find the percent of brand A if the mixture, when we're done with it, contains 27% juice. So what we know is that if we take the volume of the fruit juice or the fruit juice mix, the volume, and we multiply that by the percentage of actual fruit juice in it, we're going to get the pure volume of juice. So we'll call this a pure volume. This is the volume of pure fruit juice. And what do we know? Well, brand A is 3 liters. Brand B is 7 liters at 15%. And since we know if we multiply the volume times the percentage, if we do that, we know that brand B, those 7 liters together, have a total of 1.05 liters of fruit juice in them. And then brand C, that we know is 27% juice. But we know that brand C, or what I'm calling C, is just when I took the 3 liters of A and added it to the 7 liters of B, and 3 plus 7 would, of course, be 10 liters. So we know that so if we multiply out the 10 liters by 27%, we know we're going to want to get 2.7 liters of pure fruit juice. And if we take 2.7 liters and we subtract out the 1.05 liters of brand A, that means, brand B, then that means that brand A we're going to need to get 1.65 liters of pure juice from brand A. So that is 1.65 liters. So now we have everything we need to solve the question, which is what is the percentage of brand A, which is going to be this box right here. And so what we know, we'll call that A. So what we know is that A is going to just equal, let's try that again. No, what we know is that if I multiply 3 liters times A, 3 liters times A, that's going to equal 1.65 liters. So if I cross out my liters and I divide both sides by 3, the 3's cancel. And so I'm left with A equals 1.65 over 3, which would be equal to 0.55, which equals 55%. So we know that brand A must contain 55% fruit juice. All right, brand X sells 30-ounce bags of mixed nuts that contain 52% peanuts. Okay, so that's brand X, 30-ounce bag that contains 52% peanuts. To make their product, they combine brand A, which contains 66% peanuts, with brand B, which contains 24% peanuts. How much of each do they need to use? So what we know is that the weight times the percentage is going to equal the pure weight, or we could call it the weight of peanuts. And we have brand A, which contains 66%. We have brand B, which contains 24%. And we have brand X, which weighs 30 ounces and contains 52%. So to find out how many peanuts do we actually want when this is all over, how many ounces of peanuts total do we have to have? If we take 30 ounces times 52%, that would equal 15.6 ounces. So now that's all the information we have from our little description here that we can fill in, but we can start using variables. What we know is that the weight of A, we don't know what that is, so we'll call it A. And so the weight of peanuts would be, multiply this out, A times 66% would just be 0.66 of A. And for B, well, we know that if we know we want 30 ounces total, and A has A of it, then what's left over for B is the 30 ounces we want, take away A. And so the weight of peanuts is 24% times that. So if I distribute my 24%, 24% times 30 would be 7.2. Plus, if I distribute my negative A to 24%, that's going to be minus 0.24A. So now we can create an equation because we know that the weight of peanuts for A, which is 0.66 of A, if we add that to our weight of peanuts for B, which is 7.2 minus 0.24A, when we add that all together, that's going to equal the amount of peanuts we want, which is 15.6. So now I just have to combine my terms. First of all, I've got a 0.66A here and a negative 0.24A. So if I subtract that from both sides, I get 0.42A plus 7.2, and that's going to equal 15.6. So now if I subtract out 7.2 from both sides, I end up with 0.42A is going to equal 8.4. And then if I divide both sides by 0.42, those cancel. I left with A equals 8.4 over 0.42 would be 20. So my answer is going to be, I want 20 ounces of brand A, that's the one that is 66%. And 20 minus 10, since we know A is 20, then we have 30 minus 20, so that would be 10. So we have 10 ounces of brand B, which is the one that is 24% peanuts. And if I add these two together and mix them up, I will end up with the bags that brand X sells of 30-ounce bags that are 52% peanuts.